Hello everyone and welcome to another video. Today I'm going to be showing you how to solve the binary tree inward traversal in LeetCode. So what exactly is this problem? So we're given the root of a binary tree, so we're going to return the in-order traversal of its nodes values. So let's take this first example. If the input is 1, null, 2, 3, this can mean that 2 is 1's right child and then 3 is 1's left child here. But essentially, what this is this root here. The root is going to be a tree node. So it's not exactly in the form of a list, but the output here is going to be in the form of an integer list. The second case, an empty tree should not produce anything. And a binary tree with one node should actually print only that node. It doesn't matter whether it's an in-order, pre-order, or post-order. So let's go into the whiteboard demonstration of this. So here I actually have a tree. So this tree is actually known as a binary search tree. Now a binary search tree is very useful in binary search, which is one of the two searching algorithms. It's useful in like finding elements in sorted arrays and BSTs such as this. A binary search tree is basically a binary tree which consists of nodes where the left child is less than the root and then the right child is greater than the right value. So 4 has children 2 and 6 and they're in the right order, 2 has children 1 and 3, 6 has children 5 and 7. And this is what's supposed to be a valid binary search tree. So this algorithm utilizes recursion. In a separate video, I'm going to do the iterative approach, but right now we're just going to worry about the recursive one. So let's actually trace this and see what's going on here. So since recursion utilizes a call stack, we need to understand like what a stack is. Stack is basically a last in first out data structure, meaning that whatever you add to the end is the first one removed. Alright, so now let's go ahead into this algorithm and trace this here. So there is a main method and then there's also a helper method. So the helper method is the main thing that's going to be recursive. The main reason I decided to include this helper method is because in the main method we do not actually have a list parameter. So now what we would want to do here is go into our helper method here. So we're going to call this main method, so IoT root. Let's say the root is 4, then we're going to return the helper method below. So let's say we have the same roots and then we're going to put a new list here. So let's actually make ourselves the traversal list. I'll put this in brackets here, and then I'm going to do the call stack also as a list. So the call stack basically keeps track of where we are in our program. It's going to start at the root here, so procedure IoT helper root list. So if the root is null, we have a base case. We're going to return, let's say, a new list. And then we're going to call the IoT helper through root.left. First things first, it's going to be added to the method stack here. And then we're going to, let's call this IoT H, and then let's say 4, then IoT H, the left child, which is going to be 2. Now every time we do a recursive call, it's going to restart this method, but particularly only for the new case. So for example, it will go through this check again if the root is null, but when the root is like 2 here. The root is not actually the root, it's more like a current tracker, so that's why. Otherwise we're going to basically return a new list here. That's the base case. And then we're going to call IoT through root.left. Now that's going to be 1, so IoT H1. And then we run through the base case, it's false. And then we're going to call IoT helper through root.left. Now it's null here. We're going to say null right here. If it's null, then we're going to return a new list here. And as you see, we terminated this recursive call, so null is going to be out of the stack. Okay, where was I? I just finished drinking a cup of water. Anyway, after this, we still need to add the current value to the list here. So that's going to be the first value. And then we're going to call IoT helper through root.right. But it's null, so we reach our base case. But I'm still going to show you just in case here you don't get it. we have outh null. It's going to be the same thing. Our base case is true, so we can pop this off the call stack. And as you see, we are done with IOTH1, so we can pop this off the stack. And then we're going to add the current value, which right now is going to be 2. And then we are going to call IoT helper through root.write. 2's right child is 3. So IOTH 3. So IoT helper through root.left. I'm not going to say null because it's the same thing over and over. So call IoT helper through root.left. So 3 is a leaf basically. A leaf has no left or right children. So we can just add it to the list and remove this from the stack. And as you see, we are done with a method call to node 2. So we're back to node 4. And then for node 4, we already did the left, but now we gotta add the current value to the list. 4. And then we're going to traverse through the right child, so that's going to be IOTH 6. 6 is not null, so we're going to call the left here. 6 of child is 5, so we're going to add that to the stack. And then we are going to see if the base case is true, which in this case it's not. And then we call IoT helper through root.left. It's null, but the base case is true. So we're going to add 5 all the way to the end. And then we're going to add 5's right. Then we're going to call the right node. We pop 5 off the stack. And then we are going to add the current value to the list now. The current value is now 6 because it's at the top of the stack. And then we are going to call the IoT helper through the current node's right. 6 right's child is going to be 7. So IOTH 7. Add that to the list because, I mean, it's a leaf. Because if we call the IoT helper through root.left, then the base case will be true. And also if we call the IoT helper for 7's right, it's also going to be true, the base case. So that's why we conclude this program here. So actually, and then for IOTH6, we pop this off the stack. And then for IOTH4, we're done with this method, so that goes off the stack. And there we go, we have our traversal list. Okay, so similar to all these trees, they follow the exact same algorithm here. So let's go ahead and go into our method right here. We're going to, first of all, return Inorder traversal helper. And then we're going to have root, and then we're going to take, let's say, a linked list here. So we can create a variable here, list equals new linked list. Okay, root and then list. There we go. Okay, there we go. Now it's time for the helper method, so public, and then doing this. Okay, let's have this list integer Inorder traversal helper, and then tree node root. Alright, in the algorithm, I kinda did forget to say something here. But at the end, we would want to return the list. I sort of forgot that. My bad. We'll want to return the list at the end just in case here, because this is not a void. I forgot. So now we're going into the base case here. So if root is equivalent to null. Okay, I forgot to add something. I forgot to add the list. Okay, let's add a list called list. So if root is null, then we're going to return a new linked list. We're going to then return the list here. We are going to first call this Inorder traversal helper, root.left, and then the same list. We're going to copy paste it here, but in the middle here, since this is an Inorder, we're going to list.add root.data.
What the sigma?
Not data, it's val. Let's go ahead, try this out, and hopefully I'm not missing anything, and we're good. Now, if we did actually return a new list, here's what would happen. Also that. But we're going to improve this code for optimization purposes. So this is going to be empty here. Let's call this. If it's if, we're going to do nothing. Otherwise, we're going to call this method here. And let's go ahead, submit it, and we should be good. And as you see, our runtime is actually really nice, and our memory is fine because we utilize recursion, so once again, I'm going to discuss the iterative solution. And we did actually optimize our code. So, thank you guys very much for watching. If you guys enjoyed, be sure to leave a like, subscribe, turn on notifications so you don't miss any of my videos, and be sure to share and spread the word in order for you guys to benefit from my channel and make others benefit as well. And I'm here for your technical interviews. Thank you. Bye.